Welcome to the BioArt Revolution, an exhibition that is organized under the umbrella of the Timișoara European Capital of Culture. We have here Oana Dumitriu, the artist whose exhibition now we're gonna see. Oana, welcome to Timișoara. It's your first exhibition here. How do you feel? How do you find the context?
It's a fantastic opportunity to come here to Timișoara, and as soon as I heard that there was going to be a capital of culture here, I was absolutely fascinated in the idea that I could potentially be in it. And when I met you, and then the whole thing came to life. So it's wonderful to be here.
Now, as we walk to the next work of art, well, the first one actually, I think would be really nice to explain your family name, because it's a bit misleading for whoever doesn't know your personal history, because your family name is a Romanian family name. So how come?
Yeah, I'm unfortunately just a boring English person. In fact, my family goes back to, it's been traced back to signing the death warrant of Charles I. So yeah, just boring English. But I was married to a Romanian. I came over in 1991 and worked in the children's homes and in the hospitals for babies with HIV, doing art workshops as an art student, and it had a big impact on me. I've got a Romanian son. I'm no longer with my ex-husband, but I became known under the name, and I have a great fondness for Romania, so I really like the name, so I kept that.
Yes, and your first visit in 1991 actually inspired your first art work that uses biomaterial. So can you please explain us?
So this piece, which is called Light and Earth, it uses not only biomaterials in the form of Romanian soil, but also kind of relics, because I like to use this idea of sort of secular relics in my work, or relics of experience, or relics of the laboratory. And this was the first time I kind of did that. So this is a candle. The first day I arrived in Romania, I went to the Festival of Lights in Târgu Severin, and this was the candle I was given in the church. And this is a piece of fretwork that was given to me by a boy in the Școala Profesională numărul 6 in Galați, that he made, that we were working with and making murals for. And I made this painting as soon as I got home, and unlike a lot of my paintings, which I've sort of put in storage, this one's always stayed with me. So it's been in my sitting room at home, and it's the first time since 1991, when I was a first-year art student, I've shown it. And I really thought it kind of fitted here as a kind of starting point for the show, because the Romanian Revolution was just as important to me and changing to my life as I guess it was to many other people in this country and in this city where the notion of revolution is so important.
And that takes us to the third, the second work of art, which actually some of our audience might recognize the symbol. So what inspires you? Because we talk about the revolution in artwork as well.
So we're talking about the revolution as the Romanian Revolution. We're talking about the revolution in art and science and bringing artists into the lab. And the notion of revolutions in science, paradigm shifts in science, they're all kind of things that are inspiring this show. But this piece is a work I made in companion to the other piece. So it's exactly the same shape. And it's based on the central element of the Romanian flag of the revolution, which has the socialist insignia removed. So they cut that out. But normally it has the other, you might recognize it with the red and the blue on either side. But in this case, it's referencing this idea of the flag of quarantine, and also the quarantine that we went through during the pandemic as well. And the quarantines, so when a ship was carrying plague or yellow fever or cholera, they would fly this flag of quarantine, which would then warn people from approaching the ship. And in the case of this, I've dyed it with Dyer's greenweed, which I had to do a lot of research to find out about, but it's the only natural dye that was ever used in Romanian popular costumes. So it's the only historic natural dye used in Romania.
So if your the first artwork that we've talked about places your exhibition in the Romanian context, this one actually places the exhibition in the local context, which is the Timișoara, the city of where the Romanian Revolution started in 1989. For our audience, that just to understand the local context as well. And then we move on to the participatory sort of artwork that you display here. Can you please, tell us what inspired you? Because I can see a lot of different symbols that I recognize.
This piece is called Ex Voto, and it comprises a lot of people's different stories. It's inspired by the idea of the votive offering in like Greek Orthodox churches. They also have it in kind of Buddhist temples as well, and quite popular in kind of Catholic churches in Mexico. They call them milagros, but they make these kind of objects and they hang them in churches to either give thanks for surviving something or to make a wish for something. So you can actually go to a shop in Greece and you can buy a kind of silver votive that you could hang up. And say you had a bad leg, you could buy one with a picture of a leg on and you could hang it in the church. So you've either got a bad leg or your leg got better and you wanted to thank them for it. And they've gone to the stage now where it's got quite contemporary. So you can even buy one with a mobile phone on it. If you either lost your phone and want it back, or you found your phone or something, you can hang that up. So they have all sorts of things. And I thought they're wonderful ideas for people's stories.
So when did you start working on this one?
It was probably about 2018 or so, I think. I started working on it with Nicola Fawcett in Oxford and also Professor Maggie Smith in York, this idea of the votive. And then we started collecting them in workshops and doing hands-on workshops with lots of different people. I did workshops at Eden Project and all sorts of different places. All the ribbons are dyed with different things that are integral to the stories. So this one, for instance, and the one above is with Streptomyces bacteria. You've got the purple antibiotic that it expresses when it's stressed. There's yellow for turmeric, and the orange is Prontosil, which is one of the first kind of antibiotics. It's a bacteriostatic drug.
But the last two ribbons you added to the artwork have special significance because you've done them during the pandemic. I can actually spot some of the pandemic symbols here, which is like the hand, the mask, the hand sanitizer.
Yeah.
So can you please tell us how you manage actually to...
So these I made all myself. I decided when I first heard that there was a lockdown, I was kind of, yeah, obviously it wasn't good, but I was kind of intrigued as well, because when people ask me, and this might make me sound a bit strange, but when people ask me what period in history, if you could travel in time, would you like to go to, I always say I would like to go to 1665 in London, but with a vaccine.
I think there is a tag here with 1666.
Yeah, there's a whole section that was
1666.
There's a whole section that was commissioned by the Valkov Museum about plague history, which was an exhibition that they had during the pandemic. I think it was in 2021, but they were planning it before. Yeah, but these ones I made every day during one a day during the first lockdown in the UK, which went from when they first locked it down to when the shops opened again, which was when I marked it, and I did one every day. There's the you can find things like the what we call in England the Great Toilet Roll Wars of 2020. So there's a toilet roll. That one that you pointed out there with the mask, that was actually one of my friends, Lucy McCabe, who sent me photos of her in the hospital where she works, because she's an obstetrician. She's a consultant obstetrician, and she had, babies don't stop. They couldn't cancel births, so she still had to do that, and they didn't know how it was spread at the time. That's a picture of the first vaccine trial with the first, Oxford AstraZeneca. It's a picture of the lady there.
And since we're talking about the pandemic, I think it's a really good moment to move on to the pandemic room. So here we are in the pandemic room, where it smells absolutely lovely, and it does not smell of any kind of rotten things, you know, or smells that you would associate with pandemic hospitals, but it actually smells of lavender. Tell us why.
Well, the lavender was what this is the plague dress, and the lavender is what plague doctors would sometimes stuff into their masks, or people would carry poses of pungent herbs and spices. Turmeric was also used and things like that to ward off the disease of plague. So this piece is all about the 1665 Great Plague of London, which is kind of the most sublime moment in infectious diseases, really, because it killed a third of the population of London, but also at one point killed half the population of China. And it travelled on the Silk Road, so it came through, probably started somewhere around Uzbekistan, through Guangzhou or Canton in China, which was the largest maritime port, and then on to the Netherlands, and then on to London. And they talk about, at the time, they talk about the plague travelling on light-coloured cloth and people catching it from light-coloured cloth, and that the fact that the cloth workers in London were the first people to die, the silk merchants. Samuel Pepys in his diaries complains that he can't get the good silk and stuff because all the people are dying, so he can't get what he wants to look fashionable. So this dress is all about that. It's silk from, it's a kind of raw silk, dyed with walnut, which Nicholas Culpeper said was a potential treatment for the plague. I don't think it is, but it does smell like disinfectant if you boil up the dye. The dress is, as you mentioned, filled with and stuffed with lavender, and on the front of the dress is an embroidery, which is an actual period embroidery from that time that I managed to source, that's impregnated with the extracted DNA of Yersinia pestis, the bacterium that causes plague, that I extracted in the lab at Public Health England, which is now called the UK Health Security Agency, at Colindale in London, where I'm artist in residence with something called the National Collection of Type Cultures, which is the oldest collection of pathogenic bacteria in the world.
So the pandemics throughout the history, they actually kind of took by surprise the scientific community, yes? And it's always, you know, after the pandemic, the scientists would come together and say, or the doctors, you know, they come together, physicians at that time, they would come together and try to find a solution. And you really like, you know, to actually place your artwork in the historical context as well, because as far as I know, you start your artwork not necessarily in the studio, but actually in the lab talking with researchers. And then the second step is for you to go and dig the archives and see how people actually related to the disease throughout the centuries. And you found a really interesting recipe that would protect you from any kind of possible future pandemic. So,
well, yeah, I mean, there's this idea of drawing threads across time that's very important in my work. So, because I think that people don't change so much, and we can learn a lot from the past, and we don't look at what happened in the past enough. And I'm very interested in what's coming in the future. So the thing with extracting the DNA, they're extracting the DNA, they're whole genome sequencing it, and they're using that to understand drug resistance in plague and things like that, because there are still outbreaks of plague. Like Madagascar has ongoing epidemics of plague, and in the United States they also have plague living in the rodent population in places like Yellowstone Park. So it's not gone, and they've actually found in this epidemic in Madagascar that some of the plague has drug resistance genes, antibiotic resistance genes. With this piece, I was referencing Paracelsus's ideas. He was a physician in the sort of second plague pandemic period. So Paracelsus decided that plague was such an important problem that we needed to have a targeted amulet to ward off disease. Until that point, we would have like an amulet that would just ward off disease in general. And much like how we use antibiotics now, broad spectrum antibiotics versus a targeted antibiotic, which is much better, he wanted to create a targeted plague amulet. But he said they won't come up with this in my lifetime, probably. It's something that the physicians and of the future will need to work on. He said, but it probably would contain a toad. because, as we all know, toads ward off plague very well. And then you get this really interesting debate between the physicians of the time and over the next 100 years of what this thing should contain, this amulet, which Paracelsus called the Xenexton. We don't know why, we don't know where that term comes from, but that's what he called it. And he called it this, and then they had this debate. And the scientists later, they're like, oh, well, it should contain paste of toad, I think. Oh no, powdered toad. Of course, you're wrong with the paste of toad. That's never going to work. And actually, you think about it now, we have this sort of nanotechnology stuff. It was like it doesn't work at that level, and actually things work at a smaller level and things. So there were sort of some of these ideas have echoes, a lot of echoes. But then some of them are quite strange. So they thought, well, it should probably contain menstrual blood because you would have that in any amulet. That was always a good thing to go to. And they said, well, no, maybe the menstrual blood of a virgin. And not the menstrual blood of a virgin, and menstrual blood of the first menstrual blood of a virgin gathered on a full moon. So we got the full moon. This is the texture of the toad skin. You've got the drips of blood here, and you've got sapphires on it because, as they said in those days, well, everyone knows that if you put a sapphire on your plague bubo, that it will turn black and remove the disease. So these are all things in it, and we've dyed it with walnut here, just like Culpeper said, with the dress. But the difference between this and the Xenextons of the past is this one will actually ward off the disease. Because I worked with Professor Christine Rollier at the University of Surrey, who's currently got a plague vaccine in clinical trials, in human trials around the world where there are plague outbreaks. And so inside this amulet, and I can show you here, inside the amulet, you can just see inside is the plague vaccine. And this is based on the ChAdOx1 platform here. That's based on the ChAdOx plague vaccine platform, which they used to make the Oxford AstraZeneca vaccine as well, which for COVID-19. So it's this thing where they can plug in the vaccines.
I don't know how do you manage to actually make the pandemics look so good, because the dress is just amazing aesthetically, and also this amulet is just stunning. So not all bacteria is bad for us, isn't it? I mean, it actually does live in us, in all parts of our bodies. And you were inspired by this for this artwork.
Yeah, we're kind of like actually donut shape, and we've evolved to carry bacteria around in our gut. There's a thin membrane separating the bacteria that lives in us to the very sterile parts of our body, like the bloodstream and things like that, which don't have any bacteria in. So there's a reason they're there, and we need them. They're an integral part of our immune system, and they help us digest our food. Like we wouldn't, that was one of the first inspirations for working with bacteria, when I realized that this idea of E. coli bacteria being presented as a bad thing, when I found out that actually we all carry it and we need it to digest our food, that was you know, so amazing to me. That was sort of starting me on this route. So I've been working with Dr. Jane Freeman at the University of Leeds on this work around the microbiome, and also Caroline Chilton there, Dr. Caroline Chilton. And this piece is about Jane's research looking at what's called bacterial baptism, where you receive the microbiome from your mother at birth. And she studies a bacterium, which is a superbug actually, called Clostridium difficile, which causes diarrhea and ulcerative colitis and things like that, and can be quite deadly, which they treat with human microbiome transplants, and they actually make them at the University of Leeds, and I've done other projects about that with Jane. And this one is about how actually babies, when very young babies do carry Clostridium difficile, and it's something they have kind of from almost birth, as far as we know, but it doesn't seem to make them ill. It's when we adults kind of get it and they are on broad spectrum antibiotics, which kills off like this beautiful ecosystem of bacteria, then it can cause a dangerous infection because it'll take over like weeds growing. So this piece is about the bacterial baptism, and it has these bits of linen lace here which reference a microbiologist called Sergei Vinogradsky from the sort of 1880s that inspires me a lot. This piece is all about that, and it has embroideries on it of the microbiome, and it's inoculated with the bacteria from the microbiome.
So what do we have here, Anna? I think this is a dress that dates from the 19th century.
It's from it's about 1840 style dress design. So it's an antique dress of the period that the prostitutes who would have drunk from the Broad Street pump in London would have worn. And so the Broad Street pump's really important in epidemiology, as it's the first moment of epidemiology. And John Snow, he was investigating an outbreak of cholera in London. He tracked all the different people that were affected by the outbreak and realised that they were all drinking from one water pump in the city, which was in Broad Street. And he removed the handle, which stopped the outbreak. And it's the first ever record of epidemiology being performed. And so this is kind of about that. The dress is from the period, it's embroidered with the cholera bacillus, it's got an embroidery of the Broad Street pump, and it's an actual period dress. The prostitutes would have worn something a little bit out of date, so that's why it's a little bit earlier than John Snow's action. And it's impregnated with logwood dye and also eucalyptus, which Mary Seacole, the famous nurse, would have used to treat cholera. There's a lot of visible mending on it because it was a crumbling dress and I wanted to repair it. This idea of patching is important to me. And the dress is impregnated with extracted DNA of cholera, which I extracted in the lab at the Wellcome Sanger Institute with Matthew Dorman, and it's in collaboration with Nicholas Thompson there as well.
And I think this little dress here is also impregnated with eucalyptus,
Yeah, because they used to use it for a lot of things in those days. And in the case of this, it's called the syphilis dress, and it's an undergarment, an underdress, because syphilis was always very hidden as sexually transmitted disease. And I've been working with Linda Grilova at the Wellcome Sanger Institute, who also works with Nicholas Thompson, Professor Nicholas Thompson. And this dress is about that. And so it's embroidered with syphilis bacteria and impregnated with their DNA. And I worked with Linda to learn how to grow, culture and extract the DNA of syphilis. And this is a very new thing. People haven't been able to do this recently. So she actually said in a talk recently that I was only one of 5 people that knew how to culture syphilis in vitro, because the syphilis bacteria that have been used on the dress until then have been kept alive in animal models in the United States for over 100 years, which is kind of an incredible story. You know, they've been keeping this alive in order to be able to work with it and test it and understand it when the technology became available.
This is what I really like about your work, because you really dive into the scientific process as well and try to understand it. And I think this is a really good example. After dresses, now we move on to sort of jewelry and necklaces. And this is quite a striking piece we have here. It's absolutely beautiful in color and aesthetics. Someone actually did ask us if we are selling it because they would like to wear it. But what exactly actually inspired, what research inspired this work of art?
I've been working with the Helmholtz Zentrum in Munich in the Institute of Epigenetics and Stem Cells, and the residency started in 2020 and was obviously sort of prevented me, I was prevented from going there and visiting as I normally do and working hands-on. So I spent like over a year having weekly, like twice a week meetings with scientists from there, learning all about their research. So by the time I finally got there, I had quite a good grounding in the theory, but not the practice. So I started learning the experiments. And this is based on something called the OCT4 gene, which is one of the famous Yanamaka factors that is important for stem cells. And so it's a gene that's in all stem cells, and you can use it to turn differentiated cells back into stem cells. And these represent the histones, which we think of DNA as this double helix, but this double helix is wrapped around these things called histones in different ways. And then these histones are either joined together closely or spaced apart. And this bit where they're joined together, which is by these bits of ribbon, which represent something called the H3K9 trimethylation. Took me a while to learn that. And these ones are more far apart, so you could actually modify these. So if things are modifying the DNA or mutating it, this bit's much more easy to mutate than this bit, which is really locked down. It's 3D printed, and then it's made with wire. I used natural materials in the first place, but I ended up having to remake it with nylon wire, because I also used copper sulfate on the work, and that ate into the original materials, so I had to remake it. And the copper sulfate's there because when I was doing an experiment in the lab, the scientists then said, oh, well, now we add a little bit of copper sulfate, a tiny bit of copper sulfate. And I was like, why do you add that? And he said, oh, because the cells need it to grow. The cells need the copper sulfate to grow. And I was like, wow, copper sulfate's a beautiful aesthetic thing. And I'm always, when I'm in the lab, I'm not just trying to learn the science. I'm also always thinking, what materials can I use? How can I take it out of the lab? How can I represent this somehow? And so the whole thing is also embedded with actual extracted OCT4 gene, which I extracted in the lab with one of the scientists at the Helmholtz Centre, and that's working with Professor Maria Elena Padilla-Torres there. So
after the blue necklace, we also have another striking necklace here, which is red. Tell us about this research.
So this is working with Boku University in Vienna, working with Professor Dieter Matanovich's team in the Vivaldi project. And they're looking at ways in which they can get yeast to feed off methanol and produce chemicals that can be used to produce pigments or can be used to produce nylon. And they're trying to build or trying to create a yeast that will help them make a carbon neutral nylon. Because sometimes it's useful to have things that aren't biodegradable as much as it is to have things that are biodegradable, and that's what they're working on. So the necklace actually uses the pigments that they are working to produce. It uses all nylon materials, and then these beads and these other beads on here contain the actual yeasts and the growing cultures, and in some cases succinic acid. So they're trying to make take methanol, which was known as wood spirit because it was produced by burning wood, and make something called amber acid, or succinic acid, which was historically known as amber acid, and that's why we've got the amber on here as well, because it was originally extracted from amber, but now we can take these poisonous materials like methanol and turn it into this useful chemical that we can use sustainably. That's their vision. So this piece is all using all those materials and inspired by it.
And we can just hope that actually the research will be effective, because we don't want to end up in a very apocalyptic world that you have actually put together for our visitors at the end of our tour here, which actually it's quite an allegoric, illustration of how the world might actually end up being.
So yeah, this piece is called Archaeobot, a post-singularity, post-climate change life form. And I made it with Alex May. And when we were talking about the project, we also worked with Amanda Wilson at Imperial College. When we were talking about the idea for the project, we were thinking about how archaea are these kind of one of the branches on the tree of life, and they're actually more similar to humans in the way they replicate their DNA, but they look more like bacteria, so they're microorganisms. They're very tiny. But this one that it's based on, the robot here is based on Sulfolobus acidocaldarius, which is an archaea that they found at the hot springs in Yellowstone Park. And they think it's like the most ancient life form on the planet, or one of the most ancient life form on the planet. And it loves acid conditions, so it's perfectly happy with acid rain, and it loves hot temperatures, so climate change might be very good for it. So when we talk about like climate change ending the world, we're actually talking about higher mammals, we're talking about humans, we're talking about other higher mammals, but the archaea will love it. They'll be perfectly happy, and they'll live on in a situation very much like this visualization here, which Alex May created with me, which is the archaeobots living on in this kind of underwater world. And we were kind of hypothesizing this idea that, you know, that this idea of uploading that, you know, transhumanists talk about, that you might be able to upload your consciousness and kind of live on in silica, and whether we would live on in silica in one of these archaea. So it was, the time we were making it was, people were talking a lot about the threat of AI and the threat of climate change, and we kind of fused those together. So it's a pre-pandemic artwork, but I think it's like becoming more urgent now as well, this idea. So the piece is kind of designed to shock you into a kind of a realization, I guess, of where we might go. And I'm thinking about kind of things like sort of the tech bros and their kind of dystopian solutions that they sometimes come up with, and it would only take a kind of few false moves that we might end up like that. And the archaeobot's actually got a neural network in it, so it potentially could have like a consciousness living in it. It's sensing its environment and things like that.
Well, if the archaeobot actually shocks the visitor, the whole exhibition surprises the visitor, because this is the feedback that we actually received from our visitor. Thank you so much for putting together an exhibition that brings together the world of science, the world of art, and also has such an important educational aspect to it.
Thank you.